Alright, finally we're just going to look at some examples where you have to do some adding and subtracting and multiplying and dividing of radical expressions and then simplify if needed. I'm going to start with a couple multiplying problems. Just kind of make these up on the fly, I guess. We could do something like the square root of 6x cubed times the square root of, let's do 10x to the fourth. Okay, and so a couple different ways you can approach this. One is, you look at these numbers 6 and 10. Neither one of them can simplify because neither one has a perfect square factor. And so what we might want to do is use our exponent rule. If you can split radicals up across a multiplication, you can also combine them back together. So this actually works to combine these under the same radical and do 6 times 10, which is 60, and x cubed times x to the fourth, which is x to the seventh. Get them all into one radical and then simplify. 60 does have a perfect square factor of 4. So 60 is 4 times 15. X to the seventh, it could be written as x to the sixth times x. Okay, and so I really have 4 factors here, 2 of which are perfect squares. So I look at square root of 4, square root of 15, square root of x to the sixth, square root of x. This is a 2. That one doesn't simplify. This one I cut the power in half. That one doesn't simplify. And then we grab the 2 factors that are not in a root, put them in front, and the 2 factors that are in a root, I put them in the same root. Okay? So that simplifies pretty nicely. Now you're going to see a bunch of examples where you're multiplying 2 radicals together. This is one approach to simplifying it, is you multiply them first, simplify what's left. If you can simplify right off the bat any of these, that could help, and then it makes all the numbers smaller to deal with later on. Okay. Alright, now we can also do some division. We could look at something like, let's see, let's do a square root of, let's see, let's do 24x to the fifth over 6x to the let's go 11th. Alright, and so in this one I can't immediately take the square root of the 6 or the 24, but what I can do is simplify inside first and call this, let's see, the square root. Now I'm going to have a fraction still. 24 over 6 is a 4 on top. X to the 5th over x to the 11 is x to the 6th on the bottom. And then you just split up the root to the top and the bottom. Square root of 4 over square root of x to the 6th. Each of those simplifies. Square root of 4 is 2, and the square root of x to the 6th is just x cubed on the bottom. Okay, that's pretty neat. That works out well. Okay. So that's some multiplying, some dividing. There's other things we can do here. There's a neat trick with dividing. Let's say you had an example like 5 over the square root of x. Okay, well this one, we're going to do something called rationalizing the denominator. Typically we don't want the denominator to have a radical in it, and there's some reasons for that. A fractions are usually more useful if they don't have roots on the bottom because they're easier to find least common denominators and things like that for. So one way to get rid of a square root is to multiply it by itself, essentially square it, right? You want to square a square root. And so to do that, you want to take and multiply by another square root of x, right? Square root of x times square root of x is just x. But if you're going to multiply on the bottom by something, you've got to do the same thing to the top, right? That way we're really just multiplying by 1 to our fraction, something over itself. And so now when I simplify this, I get 5 times the square root of x on top, and the bottom, root x times root x, is simply x. Okay? And that would be the rationalized form. We call this rationalizing the denominator. Okay, rationalizing the denominator. We take an irrational number and rationalize it. Basically, we take the root and get rid of it. Okay. All right, very good. Now, the last thing we got to look at here is looking at adding and subtracting roots. And the thing about adding and subtracting roots, you got to think about roots as kind of like terms. So if I had the square root of 2 plus 5 times the square root of 2, well, how many root 2's do I have? I have 1 of them here, I have 5 of them here, I add them together, and that gives me 6 of them. 6 root 2's. And so simplifying roots, or adding them together, is as simple as combining like terms, just adding the coefficients together. And that works really nice until you get roots that are different. Something like 3 times the square root of 5 plus 4 times the square root of 2. Now this one I cannot simplify because root 5 and root 2 are different. It'd be like taking, it's kind of like 3x plus 4y. If the roots are different, it's like having different variables there. And so it cannot be simplified. Cannot simplify. Okay? Alright, now let's look at another one. Let's say I had something like the square root of 20